Hello. I'm going to try and tell you everything you need to know about .NET Core 3.0 and beyond, which is like forever, in 1 hour. So let's see how I do. My name's Jon Galloway. I work for Microsoft. I also work for the .NET Foundation. So the .NET Foundation is a separate from Microsoft nonprofit, and Microsoft's actually contributed the .NET code to the .NET Foundation. So it's in order to make it more of a true open source project. So I'm happy to talk to you about that while I'm here too. So here's kind of my plan of what I hope to go through is, first of all, just put it all in context, talk about how .NET Core 3 fits in, what we've done so far, where we're going. I feel like at Microsoft, we continue to just throw stuff at you all the time. Do you ever feel like that? Here's a new blog post, here's some new features, here's a new conference, and it's hard to keep up. So for me, what I like to do is kind of look at themes from each release and try and kind of break it down that way. So that helps me, and hopefully it will help you. Then we'll dig into some of the key features in .NET Core 3, and then just some quick recommendations on how and when to update. Sometimes you don't need to update. Sometimes you do. Hopefully, in most cases, hopefully .NET Core 3 or 3.1 are good for you. So I'll talk to you about how you can get there, and then we'll look at the roadmap where we're going next. So we talk about .NET Core as your platform for building anything, and really, I feel like that's a key feature for me. I love that I can. This past week, I was doing some web development with ASP.NET Core. I went and spoke at a college, and I was doing game development with Unity. And it's great to be able to, you're a desktop application developer during the day, and then at night you build a mobile app as part of a startup, right? So it's great to be able to take your skills, take your favorite NuGet packages and code, and reuse them. When we look at the .NET Core release history, .NET Core 1.0 was released in 2016, and even then it had been a long time that we'd been working on it. As we're getting into the more of the specifics, who here has been working with .NET Core since the 1.0 days? Okay, I'm sorry. It was a little bit rough, right? But we had to ship something. So here I'm going to kind of break this down into the Jon's version. And I put this in Comic Sans to make it very clear this is not marketing approved. This is just how I think about it, right? So I think of the .NET Core 1.0 release as ship it. You got to ship someday. You got to get 1.0 out there. Part of the reason is we needed companies, we needed developers, not just open source developers, but real companies to start using it. And a lot of people needed to see a 1.0 before they were going to start working with .NET Core and to know that we were serious, right? So that was the .NET Core. Now, what happens after you ship a 1.0? You always ship a 0.1 release, right? Where you go, ooh, well, right? So this was where we fixed. There were other things. There were new features. There was some great stuff in the one release. But I kind of think of it this way, as this was the updates. Once people actually started using 1.0, then they said, well, I can't really use it because I need this feature, or my code didn't work because of this, right? So then, after people really started investing and working with .NET Core with 1.1, then they said, wait a minute, we can't, I can build new applications, but I can't move my existing code, or I can't really build my enterprise applications because you took a lot out. And the name was .NET Core because we really went from this huge framework and we said, what is the core? How can we strip it down, make it small, make it fast, and simplify it? Well, in doing that, we took out too many APIs. So with .NET Core 2.0, that's when we added in a lot more of those top APIs from all kinds of things like Active Directory scenarios or just things that you needed for enterprise applications, things that were just required to build real-world applications. That also included the start of .NET Standard. So then after that, I really like the .NET Core 2.1 release. Up until, all through working with .NET Core 2.0, we were really working on performance, web performance specifically. And there are these tech and power benchmarks. They're not created by Microsoft. They're a community thing, and we looked out there and we saw, wow, Node's pretty fast, and PHP's fast, and everybody's fast, and oh, we're at the bottom. That's not nice, and we were really, really slow. And we said, how are we slower than like Node when we're compiled and they're not even compiled, and what's going on? So we really started optimizing our performance. We have things up on the wall that show green and red and numbers every time code is checked in, and is constantly rerunning these benchmarks. And so over time, and including a lot of community input, community pull requests, people that have been following this know of Ben Adams, who just did a ton of stuff. So we really got a lot faster. But the problem was that the code, in order to do that, was terrible. Like, I tried to look and send in some pull requests, and the code just gave me nightmares. The reason was because we needed to do a lot of playing with memory. Whenever you're building a web server, you're getting strings as input. Your HTTP requests come in as strings. Headers, posts, all that stuff. It comes in as a bunch of strings. You've got to parse it. Then you've got to create a bunch of strings. HTML is just one long string, or actually a bunch of strings that you're sending down to the client, right? And string manipulation, it turns out, was really was kind of slow, but even worse, it allocated a lot of memory, which caused garbage collection. And garbage collection is the death of performance. So whenever the garbage collector kicks in, then your performance, goes in the toilet. So we were basically managing our own memory. We were doing some things where we were taking blocks of memory and we were putting things in and managing it. That was better for performance, but the code, like I said, was really hard to work with. So we went through and refactored that into things like memory of T, span of T, and these different primitives that we were able to reuse. So that did a few things. One is it cleaned up our web server code. But number two, and much more important, we made it so that those patterns were reusable. Now that benefits you two ways. One is your code, now you can write higher performance code without allocating memory, or allocating a lot less memory. So that's great. But even better, we went back through and we said, let's look at our code that we've been writing for the past 15 years. All our string builders and string, all kinds of stuff. And we started using span of T and memory of T. And so by going, a lot of people saw moving from .NET Core 2.0 to 2.1 without any code changes, huge performance benefits. And we've kept doing that over time. But I see that as a big feature in 2.1. 2.2, we started looking at microservices. In that step, we were really looking at API-based microservices. So this was, Swashbuckle and Swagger and your standard APIs. Now let's look at September, when we released .NET Core 3.0. So really kind of, I think one of the main banner features is desktop. We made it finally so that people could take their existing Windows desktop applications and you could start using .NET Core intelligence in them. We'll dig into that in a bit. But there were a few other features, and so I kind of snuck those in here too. Blazor is kind of exciting. And then microservices part 2, kind of the sequel. And this is looking at gRPC. And then finally, .NET Core 3.1, which is due out any day now. I put on here November 2019 because that's what everything says. I would bet money that it's going to be the very beginning of December. I think it's maybe going to slip a tiny bit, but I don't know. That's me. But so 3.0 is a release. 3.1 is an LTS release, which means it's supported for 3 or more years. So the idea, though, is there are very small changes in 3.0 to 3.1. So small, I didn't even make a slide with features for 3.1 because there's very, very tiny changes. And the goal there is we want it so that you can right now write code, update your code to 3.0. When 3.1 ships, you change your target, your TFM to point to 3.1, and you're done. And now you're running on that LTS. All right? So to me, that helps put things together as far as what those releases are, where we've been, where we're going. So now let's dig into some 3.0 features. And so again, looking at some themes here. Oops. All right. So some of those themes are C#8 language features, and then a bunch of application development features. So I'm going to dig into first C#8 language features, and then we'll dig into all the other stuff, desktop and microservices and stuff. All right, so C#8, this is a big deal. I've made feature requests to Mads Torgerson before. Whenever I see him, I'm like, why don't you add this? Or I would like some nice syntax to, to initialize a list or whatever. And he says, remember, anytime we make a feature, anytime we add keywords, anytime we change the language, we're stuck with it forever. Like, we can never take it back. And so they're very kind of slow and careful. When they do release things, I guess they wanted to get it all done at once. So there's a huge amount of stuff in C#8. Some of the main themes there, safety. We'll look at nullable reference types as a big thing. There's a bunch of other stuff in there, things like asynchronous streams, things that are dealing with modern scenarios. When you're working with, like a microservices scenario, for instance, you need async streams, and that's a great example. And then a lot of just nice things like using indices and ranges and patterns and things to really kind of clean up your code. One thing that we definitely do at Microsoft and with the .NET team is, especially with the .NET team, is pay attention to what is being successful in other platforms. So if you look at things like ASP.NET MVC, at the time, Ruby on Rails was the new hotness. And everyone said, wow, MVC, this is great. And so we learned from that. And then moving into .NET Core with ASP.NET Core, we looked and said, people really like Node being able to break down and just not have this big monolithic framework. They like to be able to pick packages. And so, that was a design feature of .NET Core. In the same way, language features, you look at indices and ranges, definitely looks a lot like some other languages, and that's a good thing. We want to keep up and learn from the other people out there that are doing smart things, right? Okay, that slide here, this is a summary. There's a ton of stuff. I'll point you at the bigger list of where to go to learn more about these. This is definitely something you could spend a lot of time on, and we have not that much. But one thing that I do want to show off a little bit is nullable reference types. So nullable reference types allow you to at compile or at developer, while you're developing your code, while you're writing your code, inside Visual Studio, it'll show you warnings right in the editor. And when you build, you can get warnings or you can mark them as errors. So you can really see, as you're writing your code, when you are not checking for nulls. And start at the very beginning. So there's two cases for, and part of the reason for doing this is we see that's about the most common error. And not just in .NET code, basically all over the place. Everybody's just, blowing up the world because of nulls. So if you look at this here, we've got this green thing, and this is saying, okay, error text is uninitialized, or excuse me, error text is uninitialized. And that's because here's error text, and it's a string, right? So if we go and look at an even simpler case, here's a news model. And this one here, we've got a title, which is a string, and it's uninitialized. So what if I create an instance of this view model, and I set the title, but I don't set the URI? And then I pass that class over to a function, and that function is going to say, okay, what's the URI? And it's going to blow up, right? So there's a few cool things with this. One is you can turn this on very easily. It's just that. So I turn on language version 8, and then I enable nullables. There's all kinds of support in C#8 for I can say, and you'll see it actually in here. I can go in and it gives me hints, and it'll say, okay, I can suppress this warning here. I can do nullable enable. I can go through and tweak it all. The best case is that I actually look at my code and fix it. And I took this code from a tutorial that we have where it actually walks you through fixing this application. This is an example where you have an existing application. And what they recommend in this case is that you actually use a constructor. So you don't allow setting the title or URI directly. You have a constructor for your new story view model. And you say new story view model, and that function requires all those things, and it's gonna, you can throw no, you can basically require those at that time, right? There's all kinds of other things. There's support for, you can mark as nullable, but you can also mark. There's a exclamation point where you can basically, there's some new syntax there where you can say, I know this will never be null because of reasons. Okay, so that is a good use case. Another great use case is file new project and enable it right at the beginning. That's a lot easier, actually. And there's another tutorial where we walk you through doing that, where you start writing at the very beginning, you hit an error, and it says, whoops, this could be null. And then instead, you start by initializing things, or you use things like a constructor, or you change your coding patterns, right? So this is an example. This is kind of one of the bigger ones. There's a lot of other stuff, including, like, for instance, async streams. And this is the page for that. So you can get to that using aka.ms new C#. Right, so aka.ms new C#. And that'll take you to this page. And this walks you through all this stuff. And so some of the examples here, a few other ones that I just like. Indices and ranges is cool. So this is something where if you've ever had to say, I want the last item in an array, and you have to do -1, like length -1 or stupid things like that. So this allows you to go in and index into that array. Okay. So I can say I would like the last item, or second to last item here. Or in this case, I can say I would like a range. I would like items 1 through 4, right? So that's a nice syntax. Another nice thing here is if I go back up to the top. Oops. There's one other one I wanted to show off. Asynchronous streams is also nice. And so that's useful in cases where you want to iterate over a stream without allocating. And so you can do something like this. You can create something using an async enumerable, and then you do an await for each over that. And so, again, there's a tutorial to walk you through that. I think there was one more I wanted to show. Maybe not. That'll do it for there. Yeah, so, I guess one other one is patterns are kind of nice also. And that's an example where you can do, for instance, clean up your code to something like that. So there's a lot there. I've got a link at the very end of this. It's aka.ms new C#. But nullable reference type is kind of one of the main ones we point out. Cool. All right, so now let's dig into some developer themes. A big one here is the desktop application scenario. And then we'll look at some of the other ones. The two that we'll really dig into, wow, it just changed for me. The two we'll dig into are desktop apps and full stack, and the web applications, and then very quick look at the other ones. So desktop applications. So the idea here is by moving to .NET Core 3, you can get deployment flexibility. This is a really big deal. This is something where people have been asking for a long time for more flexible deployment options. And one of the things this gives you is single file exe. So you can actually, we'll look at this in a bit. We'll create a new web forms or WinForms application, and we'll create a single exe from that. Then there's also the opportunity to start making use of some Windows 10 features, including MSIX for deployment. So that's really nice there. But there's also things like XAML islands and just kind of all these modern features. And it's all open source, and that's exciting too. So there's updates and things going on with that at a pretty rapid pace. So one very big specific benefit there is that deployment flexibility. And we talked to people, some of the people that brought this up are large companies, and they said, I must have an animation going there. I'll talk faster. They say, hey, we've got 300 Windows Forms applications that we just use across our enterprise. We don't ship them anywhere, but we use them in our enterprise. And we can't update because when we do, it's going to break something else if we update our .NET framework, right? We've also ran into cases where we shipped an update to .NET framework as part of, say, Windows Update, and it broke other people's desktop apps. And it's all because .NET framework is a very monolithic thing. It's a single install. And so because .NET Core is designed as side-by-side and it's bring your own runtime, this allows you for each Windows Forms application to have its own .NET Core version, and you're not going to break someone else's. Another really nice thing is, I was mentioning the performance improvements we brought in. Things like strings are just faster because they used a span of T, and they also allocate a lot less memory. So it's basically, if you think of it, you're doing a brain transplant. You're taking an existing Windows Forms application and you're putting in a faster brain. You're putting in a faster engine, right? So let's take a look at that. There's two ways, and I'll show you first of all the way that you probably wouldn't do, but I'll show you you can do this thing that's neat. Is I go, okay. So I could do .NET new WinForms. And then from this is actually creating a Windows Forms application. I could develop this completely using Visual Studio Code. This is a very lightweight application. So this is using the newer CS project file. It's not the huge one where you're scared to touch anything because it'll probably break, right? So this is just that. And if I do, like, there's my application. There's the program, and there's my project file, right? So that's very lightweight. Now, you can do this, and that's great, but I think a more real-world example, which is what we're going to do, is we'll create a Windows Forms application using .NET Framework, and we'll update it to .NET Core, right? So if I go Windows Forms, cool, all right. It's my fourth Windows Forms app. So I'm doing this with 4.7.2. Okay, good, there we are. All right, so cool. And this will run whatever, it's your standard app. So now what I'm going to do with this is I'm going to, and if we look, I would say let's view the project file, but remember this is using the older project system where I actually have to unload the project just to even view or edit the project file. So that's fun. So what we're going to do here is grab that. I'm just being lazy. Okay, so there we're in the Windows, we're in that project file. Right? So there's a .NET Global tool we've released called Try Convert. And then I think it's so there I pointed it at my CS project file. So this, oh, because I have to do -p. So I have to give it the project file name. And then for the fun, we can watch here. So there it says, okay, something's changed externally. Let's reload. So now it's created this old project file. It's reinitializing. And now we can look at this newer project file. And it's, thinking. Huh. I'm running the preview. I can't help myself, so I'm going to blame it on that. And it said try convert. So it didn't say, like, I will definitely convert this. It said, I'll give it a shot. I'll see what I can do. All right, let's take a look. Also, one other excuse I'll make for it. I'm using the preview tooling for the Windows Forms designer. And that is also a danger. OK, so here, though, I can say edit project file. So there's my project file. And you'll see this is .NET Core 3. And there you go. That's pretty neat. Let's see. I'm not sure if we can open the form, but we'll try. So I actually do have the designer, but it's a preview, and I don't know. I've done something wrong. Oh, enable. I have to enable the designer preview. OK. All right. I did all my updates this morning. You can't win. So if you don't do your updates, it'll update right in the middle of your talk or something, right? If you do your updates, then maybe something breaks. So I don't know. Regardless, what's neat with this is it actually does the designer at a preview level is working with Windows Forms. OK. So now what I actually want to show you is let's now publish this and see if we can get it to a single file. So I'm going to go through and do publish, do create profile. And so I can go in now, and first I'll now I need to edit. So this is a little bit hidden, but it's there. So I'm going to say I don't want framework dependent. I want self-contained. I want to give it, we'll do WinX64. And then I'll expand this out. So here, let's look at these magic check boxes I'm going to do. So produce single file. So that's cool. And then trim unused assemblies. And that's pretty neat, too. And that's in preview. We're still like optimizing that and figuring it out. But what's cool with that is it actually builds a single exe. But if I'm not using, say, printing support, it doesn't need to put that in there. So the different .NET Core features I'm not using, it doesn't give to me. If you look at the output, it's working really hard. It's making us proud. OK. So it's still doing some stuff. And then let's go over here. So one neat trick you can do if you want to open, oh, I already had the folder open. But if you want to open a folder, you can type start dot. And that's kind of a quick way to open from the command line, open the current directory. OK. Let's get over here, publish. Still empty because it's still working. Or not. There it is. OK, so it's 88 megabytes. Now, this is the kind of thing where it is, what do you call it, CPU, it is target runtime dependent. So I've told it Windows 64. I could publish it for Windows 32-bit or whatever. But there we have a Windows Forms application. We've updated it to .NET Core 3. We could also then, as part of this, start using some of those things. Like we could turn on nullable, right? We could turn on C# 8 features. Let's see if I can make it crash, right? Actually, I forget what it was. Enable language? Let's not do it. But we could, if I remembered. So we could turn on like nullable support, right? We could start using all those cool pattern matching and indices and ranges and all those C# 8 features as an example. So that's pretty cool. Now, the stuff I showed you is basically the same except better with WPF. The designer support and everything is not in preview. It's the actual like WPF designer stuff. And but all the, like including .NET New WPF and all those sorts of things work. So. And again, the reasons for that, you've got the deployment flexibility. You've also got all the runtime API improvements, all the .NET Core features that we've added, and then performance. And given time, I usually do a demo where I run the same app using .NET Framework and then update it and run on .NET Core. And it's like a lot faster, and everyone cheers. but no time for that. Okay, neat. Let's talk microservices. So we've, over time, moved from this whole kind of monolithic development thing into breaking up into microservices. Microservices doesn't mean tiny little functions here or there, but it does mean splitting things up functionally. And that allows for a lot of things, including development and deployment flexibility. So I can have different teams working on specific services that the application uses. And if they're designed correctly, they can be deployed independently. I can also scale them independently. I've just got a lot more flexibility. When I was first getting started professionally programming, we would block off a weekend for deployment, right? And I would, stay in Friday night, and we're going to do it this time, and then we'd work till 3 a.m., and the whole deployment was failing, and then some people would stay, and some people go, and we were there all weekend, right? And the next time, I'm like, oh, this time it's going to work, and my wife would laugh at me. She says, see you Sunday, whatever, right? So that was not a good way to deploy applications, right? So by breaking things apart and designing them so that we can make small independent updates and small independent scaling and all this kind of stuff, we get a lot more flexibility and also stability there. So some of the things that we've been doing with this, AKS, definitely designing with that in mind, being able to deploy to Kubernetes, which is, I guess, all the kids are using. gRPC, so we've been using gRPC. I'll dig into that more later. That's definitely a new feature. So I mentioned with .NET Core 2.2, we had support. We had more like we had support for the word coming to my head, microservices, but it was all API based, right? It was REST based services. We're seeing that for higher performance and other development reasons, gRPC is getting pretty popular, so that's a major feature here. Also support for a worker service template and web APIs with identity. So gRPC is one of those cute acronyms where it sounds like it's gRPC stands for gRPC Remote Procedure Call. It actually originally was Google RPC, but then they changed the name. So it's part of the Cloud Native Computing Foundation, and it's built on some faster stuff. So the original REST-based web services, HTTP, JSON, text-based. So this is really kind of building on all the new stuff. HTTP 2, which has a lot of features for concurrent requests and binary protocols and magic. And then also protobuf is a really nice kind of synchronization or serialization format that has, it's binary, but it also does some really smart things like reusing known names, known headers, and stuff like that. Cool. All right. So the way it works is you use this syntax, this interface definition language. So you'll see here, for instance, we've got a message. So we have a subscribe request, and it has an event, and it has an ID and details, right? So this is not C#, this is not JavaScript, this is protobuf language, so protocol buffers. And what's nice with this is I can write a proto file, and I can share it between the client and the server. So I write it, I have it on the server, I share it out to my clients, and they can write code, they can write strongly typed code that will interact with that, right? Cool. Oh, and the wire format, like I said, binary. So very tight, very, very lightweight. Okay, so generally, I think we've talked through that. It's contract first. The contract is very simple and easy to work with, and then the wire format, not easy to dig into. The HTTP APIs are kind of the reverse of that. And I stole these slides from James Newton King. He shared them with me. He was kind of the lead developer working on this, so he kindly shared these. All right, cool. We're going to go fast and skip through this because I want to show more stuff. One neat thing is HTTP 2 has built-in support for multiplexing. So you'll see the HTTP 1.1 example on the left. By doing individual requests, it takes a while. If you can multiplex and do multiple requests all at one time, super fast, right? Notice the people are smiling a lot faster in the HTTP2 test, so that's good. All right, so there's also support for code generation here. So by writing this code, or this IDL file, then I can generate, by using these package references, so I pull in these 3 references for these files. We have a new thing here, this protobuf, that's actually in my CSproj file. I tell it about a protobuf file. And when I do that, then it's automatically going to generate code for me. In this case, I said gRPC service is server, so it's going to generate server-side code. If I change that to client, it'll generate client-side code. And a reason why we're doing this is because it's really a standard. It's throughout the industry. So people all over the place are using it. It's supported on all different platforms. Yeah. And so there are a few disadvantages. It's tougher to debug. It's binary, right? It's not a web standards. It's not your old school web stuff where you inspect and bring up your network tools, and it's very easy to use. There's also limited browser support. It requires HTTP2. There is support for Envoy, which is a web proxy for it, but it's not kind of as easy and ubiquitous as REST services are. Not human readable. There are some things, BloomRPC, Wireshark. BloomRPC is kind of nice. It's a web-based looking thing. All right, we'll look at that, and then we'll hop over to APIs. So the examples I have for this, sure. So there's 2 examples. One is, we're going to look at a simple greeter service. So this is Hello World, basically, with gRPC. This is a greeter service and a client. The client says their name, and then the server says hello to the name. I'm going to have to update my code slightly because I last showed this in Istanbul, and we don't want to say hello to Istanbul anymore. So we're going to say hello to Moscow. Cool. All right, so here is my client. There we go. So I'm just changing my name to Moscow. Cool. Spelling it the stupid way, I know, sorry. Okay, so this is a very simple client. And what's neat here is I gave it this greeter.proto file. This is written on client and server. This is mostly comments here. There's not much going on. There's a request and a reply, and there's a method. So there's a service here, say hello. And it says, the request returns reply. So what's neat with that now is when I set that up in my project file, so you'll see here, I've got, not that, I've got this, that protobuf reference, and I've told it to generate client code. So because of that, my greeter service, I say create a channel, and then now my client, I say new greeter.greeterClient. Now there's no greeter.greeterClient method that I wrote. If I go to definition, this is actually generated code, right? This is auto-generated. So if I update my proto file, if my server sends me an updated thing, then I can use that, right? So this is a very simple, run the client. Should have run the server first. Let's see what happens. It's going to explode. It's not going to be happy. Okay. So we'll run the server. Just Control F5, sorry. So an interesting thing as this is spinning up is Kestrel has support for HTTP2. So it's able to host a service. One place that does not have support for for HTTP2 and thus for gRPC is Azure. So that is one place where you can host a gRPC service in Azure, but it requires hosting it in Kubernetes or something. So at some point, they'll probably add it, but it's harder than you'd think. It requires some changes to Windows. So, all right, so that goes there. This goes. I've got the, which one is that? That's the greeter. Did I not run the server? This is a lot of work to just say hello. Sorry about that. Great, hello Moscow. Yeah. All right. Oh, thanks. Yeah. So what's nice here is it's not a lot of code. It's standard. I can work with gRPC services. They're all over the place. Super performant. If I'm writing a bunch of microservices inside my enterprise, very easy to share those proto files around and work with that. So that's pretty nice. And then there's support. There's another example I have, but I'm going to skip. Should I skip over it? I think I'll skip over it. Basically, there's another one that does bidirectional streaming. I think I can run it really quick. So this is Mailer. What Mailer is showing support for is bidirectional streaming. So you, in the past, to do bidirectional stuff, you'd use something like SignalR, or you're building very chatty things. So this has HTTP2 has great support for bidirectional support. Both directions, client to server, server to client. And so in this example, let's run this. This is a mailbox, and it's going to keep sending me messages, and then I can keep forwarding them. So we'll do that. I'll just run it, and then we'll take a look at what it does. So the server should be spinning up. Actually, it's I think well, all right, fine. Go. Okay. I ran the client before the server was going. Don't do that. Okay. Ugh. All right. Trust me, it's not that exciting. It's a console app talking to a server. The interesting thing here is that it's just built in to the protocol. So you can do, here it says stream, RPC stream, right? And this example, if you go into the docs, I've purposely picked docs or examples that you can look in the full documented documentation for, and it walks you through doing this and building this mailer service. So good stuff. All right, I also wanted to show authenticated single page applications. However, there's I'll just talk to it because it's actually very easy to do. File new project. I'll show file new project, but I'm not going to run it because the first thing it does is npm restore, and that'll take the rest of my talk time. Actually, when I last did this, I was like, hey, this is cool, and then we waited for a while, and it like npm was still doing its thing a little while later. So, all right. So if I do. Just do a new ASP.NET application. I'll just show you how you do it. So this is support for, I'm showing it in the Angular case, but it also works in an API case. So there's a few really cool things about this. One is that it actually like is tested, security reviewed, and all that kind of stuff because API and single page application authentication is difficult. So actually, in this case, you go through and clicking on things in the Angular application. It's checking your token, and it's using a JOT token and making sure that that you are you're authenticated. But another really cool thing is it's actually using Identity Server. So Identity Server is an open source application. It's an open source project, and we've worked with the Identity Server folks to ship that, to include that in here. So if we look in here, you'll see add Identity Server with Jot, right? And here, add Identity Server. And Identity Server has been around for a while. It's very well tested. And so it's really cool. Instead of us kind of making up our own thing, we worked with the Identity Server folks to ship this. And then also, if you start by building with this and then you need more advanced features, you can more easily transition to the full Identity Server. So that's cool. All right, let's keep moving. Microservices, we've done that. Let's talk web apps with Blazor. So the idea with Blazor is normally, if you're building an application with single-page application functionality, you've got .NET on the server, and then you've got some sort of front-end JavaScript framework on the client, right? And we would basically ship the JavaScript code down to you, and that's about all we would do. What's neat now is that you can actually write .NET code in the client and on the server. And the way that that's done is, and some nice advantage there is you can share your C# code, including your models. So if you're building, say, a store, and you've got products, you've got a product class on the server, and then you've got a product class on the client in JavaScript, and you've always got to keep them up to date. This way you can just use that one product class. You can also reuse other code you've written, and you can reuse your NuGet packages. You can also reuse your skills. So if you're a good C# developer and a kind of good, but not that great JavaScript developer like me, I would rather write C# code that I know is going to work, and I know I'm not going to make some weird security error that I hadn't thought of or something. So yeah. And then you still have support, too, for using all your JavaScript and browser APIs. So it's got full JavaScript interop. You can do any existing JavaScript, any Bootstrap, any CSS files. It's all standard in the client. So the way this all works is using WebAssembly. And WebAssembly is standard. It's browser-based standard, and so it's broadly supported. And anything that can compile to run in WebAssembly is supported. And so we've done the work to enable compiling .NET code to WebAssembly. So the idea here is you've got this stack with WebAssembly, then it's actually running a .NET runtime, and then Razor components on top of that. And those are your components you write, and that can also pull in NuGet packages as well. So your code is running there. You have the full DOM, so it's the HTML DOM. Sometimes people get confused when they see, okay, C# code running in the client, and they think that it's going to be XAML or something. But no, in this case, it's just standard HTML, CSS, JavaScript. All right, I'm going to go fast because we're short on time. The one thing I do want to point out here is we originally built using WebAssembly. And people said, this is great. I would like to start using this right now. And we said, well, we're still working on it, and WebAssembly is still pretty new, and we can get that to you May 2020. And they said, well, I would like something right today. I would like something right away. And so we actually built using SignalR, where we're running the .NET code on the server, and we're shipping just the changes down to the client. So there's still some really big benefits to this. You can build two big benefits. One is you can build something that works like a single-page application, but it's really efficient. You're actually, file new project is only a 200 kilobyte download. So you compare that to a lot of other front-end SPA frameworks, there's a much more significant JavaScript download. So that's one nice thing. Another nice thing is you can very easily write a server-based app and then change a few lines of code, and now you're running the WebAssembly version. So yeah, there's some neat stuff. If you want to dig into Blazor, there's a full Blazor workshop. I am at 10 minutes, so I will show you the world's fastest Blazor demo. And we're just going to look at File New Project. If you have time, though, I very much recommend checking out that pizza application. It walks you through more advanced things like building components. One thing you'll find, so here's this example. As we set this up, you can build with server or WebAssembly. I'm doing the Blazor, or the server side based. And it looks similar and then different. Yes, no, I've made problems. Okay. So if you look at a page, here's one that's actually doing something. This is a counter. It has a button, and every time you click the button, it adds one. So some interesting things that it does. One is there's some similar things to Razor pages. It's standard Razor syntax. It has routing, like you'll see that add page at the top. But there's also some differences. So here I've got a function, and I've got this @onClick. And this @onClick binds it to C# code, not to JavaScript code. And that runs this increment count. But it does run, so if this is in WebAssembly, this code would be running on the client. And otherwise, if it's server-side, it's running on the server, but it's running as part of the Blazor application. The one other interesting thing is I've got this current count property, and I'm binding to it here. And I don't have to do anything. I don't have to say, update current count, or update this or that. There's this two-way binding, and it'll automatically update, right? So there's a whole lot more to it. I can only really point you at it, but I think it is very interesting. One other very nice thing is that it's got a component model. And so we've been missing a component model in the .NET world for a while. With Windows Forms and Web Forms, people were used to component vendors and being able to go and buy components that did things like reporting and charts and all kinds of stuff. And so that is back, which is kind of nice. Yep, so Blazor.net is a place where you can go and find all the stuff. We just did a demo. All right, there's another neat thing, and I just want to show you. There's this Steve Sanderson, who's a dev on the team. Okay. So he wrote a blog post where he said, okay, they've been playing with running it on the desktop. And you know that you can run web apps on the desktop using Chromium or Electron, for instance. And Electron works, but it's kind of heavy. It's running Chrome. It's running full Chromium. It's also running a web server. It's got its own node. And so what Steve did is he actually saw, hey, every modern operating system already has a web view, so we don't need to ship a browser. And we don't need to ship a server either, because we have .NET. So he actually went through and stripped this down, and he got this whole thing down to, in the case where it's framework dependent, 0.8 megabytes. So I actually have like one of these running. If I go, oh, I wish I remember where it was. Maybe on my desk. No, I think I would just have to catch me afterwards. I actually have this running where I went through and built his demo app, and it's like, it really is like a megabyte, and it's an exe, and then there's a folder sitting next to it with the HTML files, but it's pretty amazing. The neat thing with that is it's cross-platform. It's cross-platform .NET, HTML, so that is a way of building cross-platform with .NET without using Electron, so that's kind of neat. Okay. Some other neat things, there's machine learning. The scenario we're looking at here mostly is we've got .NET developers with applications. They would like to use machine learning in their apps, and they don't want to have to learn a whole new language or a whole new stack. So I think that's kind of the main use case there. We're not really expecting all the machine learning developers out there to come flocking to .NET. It's more that you as .NET developers can now add machine learning in. So there's tons of neat stuff you can do in your applications. And there's a new, my demo here is, the fast demo is using an animated GIF. And the idea here is I'm showing, this is a Visual Studio extension that does auto ML. So basically, I'm taking a tab-separated value field, and I'm telling it train on this. And I told it which columns. I said, this column says if something is positive or negative sentiment, and the other one has just a string of text. And it goes through and tries all these different things, and it generates some code for me. It generates a model, and it generates code that I can use to call into it. So like very quickly, I don't have to go through and do a big step-by-step. I really can go through and point it at some data, and I have some working code that can run against that. There's tons of great examples in there, and like it really, this again, I'd be happy to show you afterwards. I can run through this. It's pretty neat. Cool. All right, I'm going to skip past this. There's also some IoT support, working on optimizing for working better on IoT. Let's talk about the future. So .NET 5. When we originally shipped, we actually had 3 different runtimes that we're dealing with, right? You've got your Xamarin Mono that have been out there for a while. They run on all kinds of stuff. Some things that .NET was never designed was never really designed to do, but the Mono people are just brilliant and made it work, right? So it would run on your PlayStation or your toaster or whatever. Then there was .NET Framework, which was a kind of big framework, and then there's .NET Core, which originally was really focused on the web scenarios, right? Shout out to anyone that used it when it had the K runtime and KVM. Okay, so then after a while we said, wow, we've got a lot of duplicated code, and it's also difficult for you to write shared code that runs across all of these. So we created .NET Standard. And we said, if you write something that targets .NET Standard, if you write libraries that target .NET Standard, they'll run on any of these. And really, the focus in the future is now to merge these all together. So you have one runtime. Now, in the past, you might say, well, I need to use Mono because it's going to do some certain things that .NET Core doesn't do yet. It has some really advanced compiler features or whatever. And .NET Core doesn't have those. Or I need to use .NET Core because I need to target these specific features. And see, the idea now is it's one runtime, one BCL, and then switches to allow you to opt into which sort of thing you want to use. So some of the features that we're looking at here is this single tool chain, both JIT and native model support. And an interesting thing is interop with Java and Swift. So you can scour the internet. There's not really much more detail out there other than, hey, we're going to interop with Java and Swift. But it is part of the design. Some other things. So Rich Lander, he's Run Faster 2000. And I'll have a link to that in the end notes. But as they're planning, now is a time where you can get in and you could say what you would like to see changed. So this includes API changes. It includes changes to the CLI. So this is really a time where you can go through and if there are specific use cases you have, you can send them off to Rich. You can also tell me, and I'll pass them on to Rich if you need. So some things that are not there: web forms, WCF, and workflow, and then .NET Framework continues to be around, supported, etc. For new stuff, we recommend .NET Core. So here's some of my recommendations, and I'm wrapping up here. But so new development, definitely recommend .NET Core, right? And if you build for .NET Core 3.0, then 3.1 is very quick to update to. Windows Forms or WPF, you can update those now. We saw doing that using that try convert. Web forms, I recommend looking at Blazor because it has that standard model where you've got components, you've got properties and events, so it maps pretty well over to a web form scenario. For WCF, gRPC is kind of the new hotness in remote procedure calls. There's also a core WCF project, and you can look at that. One other thing that I definitely recommend, a lot of people don't know that they're there, but if you look in the docs, there's migration guides, both for moving from like MVC, ASP.NET MVC to ASP.NET Core, and then also migrating between versions, like 2.2 to 3.0. Cool. So we're wrapping up. So the schedule, the last thing here is the schedule. So 3.1 shipping November, December. And then the idea here is we want to give you a standard, reliable schedule in the future. So Every other year is an LTS release that you can rely on being supported for 3 or more years. And then alternating with that is the other releases, right? So you can rely on a release every November. So that's kind of the schedule. And yep. So that's it. I'm done. Here's my slides. You can grab this. Now, my slides are actually not uploaded yet. They will be uploaded in, like, say, an hour. But this is where they will be. So thanks a lot, and I'll take your questions afterwards in the whatever it's called. Thank you.
Yeah, thank you, John.